Okay, so this is the alkali hydrogen fuel cell. I'm just going to go through a quick explanation of how it works. So what I've got here is some hydrogen gas that is continually pumped in. The fact it's a fuel cell means it needs a constant supply of fuel, and the same with some oxygen here. We've got a cell, this thing here. You've got to imagine this is filled with water, so we're going to get solutions, and then we have two electrodes connected to whatever it is you're trying to power, with some sort of membrane in the middle that'll stop things getting from one side to the other unless you want them to. So where are we going to start? So for the alkali fuel cell, I think it probably makes the most sense to start on the oxygen side. And just in terms of the molar ratios, I'm just going to put a little half there. Because what actually happens is half an O2 will hit the electrode. It will combine with some water. Remember, this cell is filled with water, and it will pick up two electrons from the electrode, and that will change that into two hydroxide ions. So step one, we have half an O2 plus a water. Remember, the whole thing's filled with water, plus two electrons will go to some hydroxide ions. Now, this membrane here won't let anything else through, but it will let hydroxide ions. So these hydroxide ions will pass through the membrane to the other side. They'll just diffuse across. So I'll just talk about OH, go to other side. And then at the other side, the two hydroxide ions hit the electrode with the hydrogen gas, and that produces two waters, and it will also release two electrons. That looks a little bit messy there. The H2 and the hydroxides are coming in, the electrons and the waters are coming out. So we're going to have H2 plus two hydroxides will go to two waters plus two electrons. Those two electrons will then travel up the wire, power your light bulb or whatever, go down to the opposite electrode where they're picked up by more water and more oxygen. That will produce more hydroxide. The hydroxide will go across to the other side, where it will combine with the hydrogen to make water and electrons. The electrons will go through to the right, so it just constantly keeps on happening, providing you have a constant input of fuel. And really, these are the two half equations you need to remember. There's also the overall equation. So if I was to combine and cancel these equations, you could try that yourself now. Maybe stop the video and then start it again once you've had a crack. By combining these two equations, we should end up with H2 plus half O2 goes to H2O. So what we're really doing, in a way, is combusting hydrogen, which is obviously very exothermic. It releases energy. Only we're doing it in a controlled manner so we can make that given out energy useful. We can use it for something.